Okay, so I just got finished with my workout. I did it was shoulders and tries day, and it was just doing like 8 to 10 rep range kind of thing. So I'm just going to talk about kind of like the systems and things that went through. So today we talked about like muscle contraction, like how does that go? So I have some like drawings that I'm going to show that could help like explain when I contract my muscle. So like we have these sensory nerves or things that they send up the afferent pathway to the CNS. The CNS is like, okay, we're going to integrate it, whatever, and then sends it down the efferent pathway so that it can get all the way down to our muscles. So it goes to like a neuron. And the dendrites on the neuron receives that signal. The soma cell body integrates the signal, and then that signal goes down the axon. So it depolarizes, repolarizes, depolarizes, repolarizes all the way down the axon until it gets down to the like axon terminals, and then like it goes to like neuron until it gets to the muscle. And so then like when that neuron gets the muscle, it's like, so I have my picture right here. So this is like the axon terminal, and it has like the hormones. This is the synaptic vesicles. So they have the hormones and neurotransmitters. When that signal gets sent down, it causes those synaptic vesicles to basically like fuse with the cell membrane and then exocytose like all of its content into the synaptic cleft. And then you have these little like what are they called, like bind, like things that like they're on the membrane, they bind and they take like those neurotransmitters, and then you get a signal. So you get an EPSP, IPSP, or no change, and that signal goes down like into the T tubules, and then that like signals like in the sarcoplasmic reticulum, which has all the calcium. It basically like releases calcium, and then that calcium binds with troponin, and then troponin is on the tryptomyosin, which is on the actin, and that basically like opens up like the flap of actin so that myosin heads can bind onto that little binding site. And so then when a phosphate or an inorganic phosphate is released, 50% pull. And then when the ADP is released, 50% pull, so you get one full pull. And then when you get ATP to come in, it basically breaks off the myosin, and then recocks, reloads, we're ready to go again. And you need like a lot, like hundreds, thousands of these things to happen in order for me to contract my muscle and to get that force going. We have like Golgi tendon organs and muscle spindles. So the muscle spindles are like with the lengthening. So like that's like sensing like, okay, she's pulling this, so that means that like it's shortening and lengthening muscles. Like this is lengthening it and this is shortening it. And then the Golgi tendon organs are basically like senses the change in like tension. So like basically it's kind of like a safety thing. So like if I'm pulling and I can't lift it up, that's kind of a safety thing. Like she can't pick it up. If she does, then it could rip her muscle. So it stops me from being able to do that. What else? So it doesn't last more than like a few, like 10-20 seconds. So we're not really going into any like aerobic energy system. We're definitely using mainly PCR and some glycolysis. It's not really like a long period of time, so we're not like burning fat. It's more like carb based. And it's like quick, and so the PCR gives me that quick energy, like when I'm first on set, like grabbing the muscle or grabbing the weight and doing what I need to do. And then I start to get really, really tired fast because my body can't pick up that weight anymore. So then I get like muscle fatigue. And I'm trying to think that if that's pretty sure that's all. Like, I mean, I did a good pump, which I talked about with Dr. Hyde, about how like the blood flow and the hydrogen ions and the lactate, how like that gets built up, and then all that blood and everything like creates like that pump, and then it goes away because it eventually goes through, like keeps flowing, but it takes a minute. But yeah, mainly PCR and glycolysis a little bit, but not too much. And yeah.